Hello there, I'm your host Dan Rojas, and today I'm going to be talking to you about Stirling engines. And this is a prelude to a video where I'm going to actually show you how to make a Stirling engine with completely off-the-shelf parts. Now, we're going to be taking this particular Stirling engine apart and looking at basically how it works. Before we get to this engine, I want to talk to you about this Stirling engine. Now, this Stirling engine uses this reflector to gather the heat that actually makes this engine run. There's a big misconception about this particular engine, mainly because of a video that's on YouTube that somebody else did, but the misconception is that this engine has hydrogen as the heat exchanging gas in there. And this engine, there's the displacer piston, and you can see that I'm putting the cap back on it. This engine runs off of regular air, so any hydrogen that's in that does work, but it is not a pure hydrogen engine. None of these are actually, for the simple reason that you could put hydrogen in there and get this started, but since these run at 1,000 RPMs, after about 10 minutes or 10,000 RPMs, you're going to end up with air mixture, because while these are a closed loop system and they're not designed to have any outside air come into them once they're running, there is a little bit of leakage that happens, and hydrogen is very difficult to keep sealed. So if you were to do these as a completely sealed engine, it'd just be a very difficult process. Now, I'm going to get back to this engine, and this engine has basically 4 components to it. It has a displacer piston, it has a heat sink that actually allows the air to condense, it has a sealed piston, and it also has a flywheel. So we're going to start with the displacer piston. Alright, you can see this displacer piston, it's got a metal pipe around it, and this right here is a very lightweight, hollow canister. And you're going to notice that it's not perfectly sealed, and this allows the air to run around it. All Stirling engines that we have are basically that way. So what I'm going to do is I'm going to go ahead and pull this off. So you can see that we have the cover off, and this is the displacer piston. This is a very lightweight, hollow piece of, this is actually a piece of aluminum. And this is the steel casing around the outside. And when this piston is in the extended position, it actually comes to the very end of this pipe. A big mistake that a lot of people make is they leave too much space up here, and their engine just doesn't work very well. Now, when this piston comes to the back position, you can see that it actually goes all the way and almost touches back there. So this engine transfers very little air back and forth. It's a very, very tight setup. Now right here, this engine was made with a metal lathe. So there's basically a hole that was cut here, and then the sealed piston is on the back side, and this is actually the hole that was cut for that. So the air just transfers back and forth through that hole right there. So it comes back there, goes right to there. Back here we have the other side of that double cut circle that I just showed you, and this is the sealed piston. Now this piston on this engine does not have a gasket around it like a piston for a compressor would have, or like an engine with the seals that they would have. The reason that these don't have that is because that would create too much friction. While it would be a better seal, the friction would just kill this engine. And these engines, friction is their biggest enemy, so that's something that you want to avoid. Now you're going to notice that the diameter of these pistons, this is about twice the diameter of this, and this is usually about what most Stirling engines are. The displacer piston is usually close to 2 times the diameter. It varies depending on different designs and the length of this, but we'll get into that later. This piston, the sealed piston, actually follows the displacer piston at a 1/4 turn. So they're a 1/4 off. That's what this really complex, actually this is an overly complex way of doing it, but they're a 1/4 turn difference, and that's important. They're not, a lot of people think that they're half off like a standard engine would be. They're not. They're a 1/4 turn, so you basically have that. Now, the flywheel on this particular engine was, this was a machined flywheel. There's a lot of places that you can get flywheels. The flywheel needs to be as balanced as possible. A good place to get those, you can look on eBay and get timing chains for cars. These These are actually perfectly balanced. They're designed to have a lot of RPMs behind them. And here is, one might look like this, and I bought this for $3 with shipping. It came to like 10 bucks. New ones, you don't want to get a new one because you don't want to pay $89 or 100 bucks for it. This one is from another type of engine. They're all going to vary, but the good thing about these is that they're balanced. They have a nice weight to them, and they'll work good for this process. One of the most difficult items to find off this shelf for a Stirling engine is the displacer piston. It is actually a light, very light piece of metal. This one is thin aluminum, and this will actually float on water. It's full of air, so it's kind of like an air can, more or less. As the Stirling process takes place, it almost blows this back into this position versus an actual compression because, again, it's not sealed, so the air flows around it. So this has to be very light. Now, a great place to find these is just regular metal cans. You want to find some that are sealed without the extra ridge up there like spray cans have. So you want to look for one that's been molded into one complete piece like this one is. This is an orange spray that we happen to like a lot. For the rod assembly that runs into this, I have this right here, and you can see this is nothing more than an air fitting. Okay, this is just a regular air compressor fitting, and it happens to fit into this drill paddle bit. So I've attached the can to it. You keep all of this here because it's perfectly centered, and you can see that this slides back and forth. So this is basically this, and we can lengthen this accordingly. Another item is the heat sink that's on this. Now, instead of machining one, which is, if you have the access, again, go for it. But you can get regular heat sinks for computers. You can buy those off of eBay. You can buy them in lots where you get 10 or 15 of them. They come in all different shapes and sizes. So that's something to look for, is heat sinks. It's going to be a little bit complex on how to get these around this, but I may have a different solution by the time I get to the video. But just something to keep in mind. The pipe around this, the actual outside of the piston, is just a steel pipe. Now this one doesn't fit in there perfectly, so we're going to have to actually bore some of that out. That's just basically sanding it with a drill and a brush attachment, or there's different ways of doing it. So we've covered everything but the sealed piston. You can find those just about anywhere. This is the compressor that we used from one of the videos, and I went ahead and took that off, and you can see that there is actually a piston with a ring around it. Now, you may have to sand this part down because you don't necessarily need that much of a perfect seal, and you don't want the friction again. But start looking for compressors that have pistons to them, and don't take it apart yet because there's ways that you can actually just hook this up and get around this whole process right here. But this should give you the basic starting point of what to look for with Stirling engines. Again, the video, I'm going to go ahead and work on it over the next couple weeks and try to get one completed, test it, make sure it actually works, and then we'll go step by step on how we did it. I'm your host, Dan Rojas. Thank you for watching, and enjoy our videos.